So in this clip, we're going to briefly discuss the internal structure of the Earth. It's important to note that we've only really managed to drill a relatively short distance into the crust. So what we know about the Earth is largely from geophysical data, specifically looking at different, seismic waves from earthquakes. So we have a decent idea of what's down there, but we can't be 100% certain. But what we do know is that the Earth can be divided into several compositional layers and several structural layers, and these are different from one another. So the traditional model you've seen for the Earth's interior probably looks something like this, where you have a crust, a mantle, an outer core, and an inner core. And this generally corresponds to Earth's compositional layering. And the idea is that with this model, when the Earth was very young, heavier elements sunk down to the center of the Earth, thinking like nickel and iron, forming the core, which is solid in the inner core due to pressure and liquid in the outer core, but both compositionally they're relatively the same. They're nickel and iron. And as we go up to the mantle, we still have lots of iron, as we have iron at the Earth's crust. It's not a perfect system, but the mantle is richer and heavier stuff like iron, magnesium, so on and so forth. And then the crust is richer in silica and aluminum and things like that. So that's Earth's compositional layering, but there's also Earth's structural layering. So looking at whether things are solid or liquid or something else. And we're going to use generally pretty different terms here. So we'll start with the lithosphere. And the lithosphere describes not just the crust, but the really uppermost part of the mantle here. And why do you group this upper part of the mantle when it's different compositionally from the crust? Well, because both are solid. And it's the crust and this uppermost chunk of the mantle that form your tectonic plates. So every tectonic plate's dragging around a bit of mantle with it. And this is solid material. It deforms, generally prettily, but with lots of exceptions. But as you go down, you see the asthenosphere, which is sort of solid, but it's plasticky. It's gooey. Think of it almost like applesauce. So it's not liquid. It's not all magma like many people think about the mantle, but it's liquid enough that you actually can have some flow and some convection currents. And the lithosphere can be thought to float on top of this more gooey substance that's the asthenosphere. So you have what's called, it's been described in literature as sort of being like a plasticky layer, not quite solid. But I like the term gooey better. I think it's more descriptive. Below that, we get the lower mantle, and surprisingly, despite what you might think, the lower mantle is actually more rigid than the asthenosphere. So it does, like the asthenosphere, move over geologic time in these convection currents, which we're still not sure quite how they work. But it is more rigid, more solid than the asthenosphere. It can be thought of as pretty solid. Below that, though, is the outer core, which, unlike all the previous layers, we know actually is liquid. And we know it's liquid because, unlike through the rest of the Earth material above it, the certain seismic waves don't go through the outer core. Those are S waves, if you're curious. And other types of seismic waves, known as P waves, they do go through the outer core, but they're sort of refracted. They're bent kind of inwards. And the inner core, however, the pressure gets high enough that it is actually solid. So that was a quick overview of Earth's compositional layers as well as its structural layers here.